Welcome to the Crater Rock Museum's video tour presentation, and thanks for visiting. Our museum, founded in 1954 by Frida and Delmar Smith, has an extensive collection of specimens, including crystals, geological formations, petrified wood, gemstones, meteorites, fossils, and artifacts. Our 12,000 square foot museum houses some of the best mineralogical items in the Pacific Northwest, including the fourth largest rhodochrosite crystal in the world. Our museum is managed by the Roxy-Ann Gem and Mineral Society, a club with hundreds of members all across the globe. Although we don't have a secret handshake, our club is still fun to be a part of. As a member, you can come to our monthly meetings and talk about rocks, eat cookies, and even go on field trips with us to dig up agates, petrified wood, and fossils that you can add to your rock collection. But what do we have in our collection, you ask? Well, we've got a little of everything. Actually, more like a lot of everything. The world isn't going to run out of rocks anytime soon, and it's our job to make sure we display the best of the best in our museum. So what kinds of things do we have on display? These rocks might look kind of boring right now, but sometimes all it takes is a little illumination to make them shine. Some rocks contain special minerals that glow in a black light. This type of light is called ultraviolet light, and it activates the special molecules inside of the rock, making them vibrate so much that they actually glow in the dark. This phenomenon is called fluorescence, and you can learn more about it in our fluorescent minerals display. This lumpy rock doesn't look like much either, but it came from outer space. It's what we call a meteorite. A lot of the meteorites we have on show are from China, Russia, or North America. There are 3 ways to determine if a rock is actually a meteorite. The first method is to simply weigh it. It doesn't seem like it, but even this small meteorite weighs about 14 pounds. That's because it's made entirely of metals like iron or nickel, which can only form naturally in space inside of a star. The second way is to test to see if it's magnetic. If a magnet sticks to it, there's a chance it's a meteorite. The third way is to look and see if it doesn't have any sharp edges. As meteorites come hurtling towards our planet Earth, they start to burn up in the atmosphere, moving so fast that they actually begin to catch fire and melt from the heat. This means that there will be no sharp edges on the meteorite by the time it hits the ground, and most meteorites actually burn up in midair. If your rock meets these 3 criteria, then it could be a meteorite. It could also be something else that formed on Earth but only looks like a meteorite, such as magnetite or josephinite. Both are magnetic and heavy, but aren't from outer space. We call these meteorongs. This one looks a bit like a tree, and that's because at one point it was. Before it petrified or turned to stone, this tree grew millions of years ago, maybe even when the dinosaurs were alive. Scientists believe that at some point it fell down and was buried beneath the lava of a nearby volcano. Being wood, it then rotted away, leaving an empty space behind in the lava. Over thousands and thousands of years, the empty space, called a void, filled with water containing the right elements for a mineral called jasper, a variety of quartz. More time passed, and the water evaporated away, leaving only the jasper behind. All it took was a lucky geologist to dig it up, and voila! This type of petrified wood is called a limb cast. There are other types of petrified wood as well. We have just a couple in our petrified wood hall, where you can see this giant redwood slab. It grew millions of years ago when the redwood forests were in Arizona rather than California. But that's not the only type of petrified wood either. This one looks very different compared to the other 2, and that's because it's a different type of wood called palm. Just like human beings have blood vessels in our bodies, palms and ferns have water vessels in their trunks to bring the water up from the ground to their leaves. Each one of these little round things is a water vessel. Even though it has petrified, the pattern of vessels is still preserved in the stone, which scientists can study to learn about life millions of years ago. Limb casts and petrified wood aren't the only thing we have, though. We also have this weird thing. No, it's not a petrified soccer ball. Soccer did not exist when this formed. It's called a thunder egg, and it was created when lava pouring out of a volcano became frothy, kind of like when you're drinking hot chocolate and it has a lot of bubbles on the top. As the lava cooled and hardened, so did the bubbles, leaving a hollow space inside. Over time, just like with the limb cast, the insides of the bubbles filled with material called agate. When geologists cut them open, they find amazing patterns and designs on the inside, and sometimes even crystals. Each thunder egg is one of a kind. Some of them even look like silly faces. This one's got a lot going on. It's got 2 thunder eggs attached to one another, water lines that formed when the water inside was evaporating, round bubble-looking formations called botryoidal agate, and it's also a geode. Geodes are always hollow on the inside, no matter whether it's a thunder egg or not. You can find thunder eggs that are geodes, thunder eggs that are not geodes, and geodes that are not thunder eggs. As weird and funky as they are, thunder eggs are very common in Oregon and were even declared the Oregon State Rock in 1965. Among the other things we have on display here are opals, which can also be found here in Oregon. There are two types of opal, precious and common. Most of the opal found here in our state is of the common variety, but some of the prettiest, most precious opal varieties come from Australia. Shiny! You wouldn't think that fireworks and rocks have anything in common, but they're actually very similar in a surprising way. When someone makes a firework, they add special chemicals and minerals into them to make them explode in all the colors of the rainbow. Just like in fireworks, the chemical composition of a rock determines what color it will be. For example, the chemical sulfur will turn a firework yellow. In the same way, sulfur inside of a certain mineral will cause yellow coloration. Chlorite will turn a rock green, magnesium will make it black, and manganese will cause it to become pink. A general rule of thumb is that the brighter the color, the more toxic or poisonous a rock is. The same goes for poison dart frogs, but we're not a poison dart frog museum. One of the things we have the most of are crystals. Crystals come in all shapes and sizes, just like people, and we have thousands of them. Quartz crystals are some of the most common, and in fact, the mineral quartz is the most abundant mineral on the planet. Mineralogists can divide crystals into groups based on their properties, like how hard they are, their coloring, how many sides they have, and what their chemical properties are. For instance, another crystal group is the beryl group, which contains aquamarine, emerald, morganite, and heliodor. What is that? It's not a petrified snowball. It may look soft, but this crystal, called zeolite, is splintery and sharp to the touch. It's also extremely fragile. It can be found in Oregon too. Believe it or not, this thing is also a crystal. It's a metal called bismuth, and it grows naturally like this in the ground, though most specimens are grown in a lab to ensure the best color. Have you ever had a stomachache and taken a pink medicine called Pepto-Bismol? Well, that's what's in it. Licking this crystal would be like drinking a whole bottle of Pepto-Bismol. It's also a type of lead, which is very toxic, so don't lick it. Licking rocks is always a bad idea and very unsafe. Although it may have the same colors as the bismuth, this is not a crystal, but a crystalloid. It's a type of volcanic glass called obsidian, which is also common in Oregon. The rainbow of colors comes from layers of ash trapped in the glass, which reflect the light as it hits them. Obsidian forms when liquid flowing lava cools at a very fast rate. It was often used to make arrowheads and tools by the native peoples that lived right here in the Rogue Valley. Through a process called flint knapping, a person could shape a piece of obsidian, flint, or chert to create a sharp point, which could then be used for hunting. Our museum houses a larger collection of arrowheads and projectile points that were found here at archaeological sites or just lying around. People have lived all over here for thousands and thousands of years, which we can tell by looking at their tools. These stone tools are thousands of years old and have stood the test of time better than the more fragile obsidian ones in the picture, even though the obsidian ones are only hundreds of years old. We can also study the size of the arrowheads to see what they might have been used for. Scientists think the larger ones were probably used to hunt deer and turkey, while the smaller ones were used for rabbits, squirrels, and even fish. Other artifacts in our collection include mortar and pestles, fishing and net weights, baskets, and clothing. Humans weren't the only thing living here thousands of years ago. Even right here in the valley, we had some pretty interesting prehistoric animals, such as this guy. A lot of people would call this a saber-toothed tiger, but scientists think he might have been a bit more like a cougar or mountain lion, so a more accurate name would be saber-toothed cat. However, he also has a fancy scientific name, Smilodon. This is really easy to remember because of his nice friendly smile. Smilodons used to live near the last ice age, along with mammoths. We have several mammoth bones and tusks in our fossil room, including one big old tooth. When paleontologists see flat teeth like this one, they know that the animal was an herbivore and ate only plants and leaves. Mammoths would use their flat tooth surface to mash the leaves into a pulp so they could be digested. This tooth is bumpy. That's because, like human beings, it evolved to eat both plants and meat. This means it's an omnivore, so it liked salads and steaks. Back then, humans didn't have the option to become vegetarian. They had to eat whatever they could get. Smilodon, on the other hand, only had sharp teeth. This means that it's a carnivore, or an animal that only eats steak and doesn't like salads. Before Smilodons and mammoths had even evolved, there were dinosaurs. We have many dinosaur fossils, casts, and replicas on display as well. Each one is at least 65 million years old because that's when the dinosaurs went extinct. We think these eggs were laid by a hadrosaur, a dinosaur that only liked salads and likely had a duckbill-shaped snout. We put these eggs through a special machine called an MRI machine because we thought there might be baby dinosaur skeletons inside. Unfortunately, the eggs were empty. If you were wondering whether or not we could have revived the dinosaurs in the eggs using their DNA, we already have 5 whole movies telling us why that would be a bad idea. Even before the dinosaurs, other life forms lived here on Earth, which we can tell by the fossils they left behind. The shell belonged to a creature called an ammonite, which was a squid-like animal known as a cephalopod. It started out as a tiny little thing, growing its shell around itself like a fingernail, and swam around eating shrimp, krill, and other shellfish. Ammonites can range in size from teeny tiny to huge. This big guy weighs over a ton now that he's turned to stone, and he was probably so heavy even when he was alive that he likely had to just lay on the ocean floor and eat whatever swam in front of its face. Can you imagine going scuba diving and seeing that lying on the ocean floor beneath you? Yikes! Luckily for us, they are now extinct, though other similar animals still survive today, like the nautilus. Billions of ammonite fossils can be found all over the world, though. Another prehistoric creature that survived for millions of years and also left behind billions of fossils was the trilobite. Similar in appearance to a horseshoe crab or a pillbug, trilobites were small critters called arthropods and ranged in size from the size of a pinhead to 2 feet in length. They mostly lived on the bottom of the seabed, sometimes hunting for prey, but mostly scavenging. Yes, that's exactly what it looks like. Coprolite is the fancy scientific name for fossilized poop. It comes in many forms, from cow pie to the quintessential turd shape to the good old-fashioned poop emoji. As silly as it seems, scientists can actually learn a lot from studying the fossilized dung of an extinct animal. When we look at it under a microscope or run chemical tests on it, we can tell what that animal liked to eat, whether it was male or female, if it was pregnant, and even if it had to migrate for its food. And, surprisingly, it's so pretty on the inside that people actually make jewelry out of it. Don't worry though, it's turned to stone and no longer smells or has germs. Take a look at our fossilized poop collection in our fossil room to see all the different varieties of coprolite. Those are just some of the highlights of our museum's extensive collection. As you look around, see if you can spot all of the things we've talked about in this video today. Make sure to ask lots of questions, and most of all, have fun.